explosive chemistry. Before we start, people on the front row with safety glasses, could you put them on? We've got so many people in today, it's just for your safety. Some of the reactions I will be doing today are very explosive. They're going to be very loud. You'll know those ones. You'll hear this ringing in your ears as something gets flown across the hall. When I'm doing the experiments, can you listen to what I say? Because there's lots of interesting facts I'm going to tell you about. Cheer, applause at certain points in the lecture. That's fantastic. At one point, I will tell you, I will need to go up to the top there because there's an experiment at the top that will go through all of you later on. And there will be some audience participation today, so I'll be dragging some people up onto the floor here to take part in some chemistry experiments. I would just like to thank your teachers for bringing you today. I really do hope you have a great hour's lecture from me. I'd like to thank, first and foremost, the University of Plymouth, who supplied me with liquid nitrogen today and have always been fantastic people to support our chemistry week. Okay? Let's enjoy it, okay? Okay. Over the last few millennia, one of the greatest discoveries that man ever did was time. And throughout this lecture we've got to time it. We're going to make some clocks. And here what we've got is a chemical. If I shake it, if it went from clear to what colour? Pink. To? Blue. And finally, yellow to? Red. Green. Now what happens here, I've got a special coloured compound in there called resazurin. I've got phenolphthalein in another one. What they do is they pick the oxygen up from above the bottle, and as they get oxidised, they start to change colour. And once they've changed colour, they release that oxygen back out. And they'll go back to their original colour in a certain period of time. So throughout this lecture, if any of those change colour, young lady there, young man there, you shout now. If any of them change colour, you shout now. Sorry? Now, which one? This one, and we change it back to blue. So you're going to tell me, we're going to time how long it takes for this lecture to last. So it's your job to tell me when those are coloured, change colours. Are we okay with that? Yeah. So I can't, it's not very loud. Have we got anybody here today? Good. Anybody there? Yeah. Is there anybody in the audience today?
I don't know, sir. I can't hear that.
Is there anybody out there?
Yeah.
Fantastic. Good. So we can also, these ones will change by themselves. We can do some chemical reactions that will change colour by themselves. Is that now? Oh. I'm going to get very tired of that in a minute. Aren't I, Asmin? You're going to be doing that one.
Yeah.
So, what we're going to do is we're going to do another experiment. These are clock reactions. What happens? They take a certain amount of time to show something, show a colour change. So we add some dye into here, this purple. I'm going to add in one of my special mixtures. What will happen? Just watch that one. As a reaction ceases, we can't see anything at the moment. But I assure you, a reaction is starting to take place. Yeah, maybe you can do that one. Just keep watching that solution there. Something will happen. It was purple. We've added some chemicals to it. And as the reaction takes place, what colour have we got to now? What's happened there, one of the chemicals has produced acid. I had an indicator in there that indicated it was alkaline, it was purple. And as the chemical reaction has taken place, it slowly produced acid over a period of time. Changing the indicator from purple through to yellow. And as you can see, it's all right, don't worry about that. We've gone to yellow, we're now into some acid. And the reaction is taking place. We can also do these oscillating reactions to measure time by doing this reaction. This is known as the Briggs-Boucher reaction. And we should see, again, a lovely colour change. In the solution. What colour are we now? Orange, we've changed to orange. I add solution to colour B. Get these all mixing together. Now we have which is very good. She's very, very good. So if we give this a quick stir, you can see this reaction will oscillate. In a minute it will go an orangey bromine colour. As bromine is produced, a second reaction will take place. And we should see that starting to go clear. And this will oscillate by itself throughout the reaction. So time, we can monitor it through chemistry. So chemistry is really good. It's really good at helping us monitor time. Now, time was very good. A good discovery by humans. Man, years ago. What was the next best discovery?
Cheese.
Cheese? No, not cheese. What was the next best discovery man ever did?
Sliced bread.
Fire! How do we make fire? Well, we could light a match. I could light a Bunsen burner. But I do it in a much better way. And if we can have the lights out, Chris, what I can do is I can make instant fire. Just by adding chemicals together. And as you can imagine, doing all this chemistry, it's very hot. And I needed a glass of water. Thank you, Chris. Do you have a light, please, Chris? So as you can see, we can make fire in a number of ways. We'll just let those burn off. It will be a bit smoky most of today. All right. So, fire was a really great discovery that man had. We were able to cook our food, warm our houses, warn ourselves of danger, we haven't seen predators. But fire and explosions can